don't listen to that. Listen to me. Just listen to me, your maths teacher. Don't listen to anyone else. Do you have your laptop with you?
In the library.
In the library?
Someone else.
Do you have your laptop?
Yeah, because we use that in the morning tutorial.
Good.
But
Do you have your laptop?
my laptop is.
No. Do you have your laptop?
Yeah.
3 of you have it.
Yeah.
Okay, that's good.
We need laptop for.
No, you don't need to. If you want. If you want. Okay, next maths lesson. Summer.
Oh.
Summer.
Finish.
No, please.
How about last one?
No.
What were you asking him?
The notes from last class.
He has the notes, the product rule.
Just
you don't have the notes.
Just
No, the multiplier.
Yeah. You watched the video.
Yeah, but I didn't take notes.
You should take notes as you watch the video. Okay. So what we're going to have a look at now is the quotient rule. Okay? So the quotient rule is when you have problems like this. You have a function over a function. Now, oh come on, don't make me tired.
Sorry.
So, if you have x squared over sine x, okay, dy dx is not 2x over cos x. No. That would be too easy. We need to figure out the rule. Yeah?
Okay.
Are you ready, Summer? What are you doing?
It's a new.
Okay.
You can.
It's a new class.
Yeah.
You can notice.
Yeah. We did that last time.
Only this is the
Only
notes.
that last time.
This.
That only
Oh.
this.
No, that's all he wrote down.
One page is not. Like. How many pages?
I did a few examples.
Yeah. Okay.
Okay.
Just one page.
Just it?
Should be 3.
Three.
Yes.
Just one. I think you just one page.
It depends how big you write. Okay, let's have a look. Oh.
QUOTI.
It's the name of the lesson.
Yeah, that's it.
Quotient rule.
Quotient.
There.
Okay.
Alright. So let's try and figure out this rule. So we have delta y over delta x equals f x plus h over g x plus h, and then fx gx all over h like that. That's what's Ben, do you remember what this is called? This rule?
Product rule.
No. No. First principles.
Oh.
First principles.
So it's not.
Huh? Who's that going to be? New student?
Sorry.
Ah, what did you forget?
Notes 5.
Ah, what notes are they?
Like application.
Oh, you need to be more careful, okay? Alright, I'll see you.
See you.
First principles. You remember this from semester 1?
Yeah, but I thought the proof is not that important.
What is everything's important. In,
In math one, we talk about this.
At first,
drives me crazy sometimes.
the limit and h equals 0.
Oh my god.
Correct, go. Limit h goes to 0. Right, let's continue now. You see, Summer, take good notes, okay?
Okay.
Right. Now, what I'll do next is I'll add the top together. So I'll put it over gx plus h, gx. fx plus h, gx. Minus fx, gx plus h. Like that. Yeah? I crossed, yeah. Now what I'll do next is I'll bring that h up to here. Yeah? And then next, I'll say this is f x plus h gx minus fx gx plus fx gx minus fx gx plus h over gx plus h gx h. So I've added this piece in the middle. Total is still 0 with the red. But what I can do now is in the first two I have something in common. What's in common in the first two? Gx. So I can say gx bracket fx plus h minus fx minus fx and then bracket gx plus h all over gx plus h, gx and h. Okay. Right, now you can make, if you like, this, well, let me split it. So I can say this is gx, and then this piece here is fx plus h minus fx over h minus fx times gx plus h minus gx over h all over gx plus h gx. Now, what happens when h goes to 0? So, I get dy dx. This is g. What does this become? What is this when h is 0? Yeah. What's that called?
What?
Principle.
No.
Notice. You don't do that.
No. That was bracket. That's
No.
What are you thinking about?
Derive.
Yeah.
Derivative.
Derivative, yes, Ben. G f derivative minus
F or X.
fx.
and what does this become?
F G.
Yeah. No. Go on, try, Ben. Go on. Go on. Yeah. Go on.
Derivative.
Derivative over. Come on, you two, wake you up. When h is 0, what does the bottom become?
G.
G derivative.
Ah, no.
Just the G.
No.
Just G derive.
No.
G y.
Gx plus h.
No.
2G. I don't know.
G2.
Oh my goodness, you guys, wake up. G squared.
But why?
Yeah, it's G2. Yeah.
G multiplied G.
But did
SG.
you do dy dx?
What? What are you asking me? Oh my goodness.
So if h equals 0,
Yeah.
the bracket is not 0?
No. That was the whole first principles lesson. You got your first principles. Here. Okay, when h goes to 0, it's not 0, it becomes the derivative. Remember this whole lesson?
Okay, but
I missed this lesson.
so
I think.
okay, but why g multiply g is g squared is not 2g? G squared, yeah, but you did dy dx.
I didn't do dy dx.
Do dy dx and it's
No,
g.
no, 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 no. I just make h 0. When h is 0, this becomes f derivative. This becomes g derivative. This is still f. This is still g. And this becomes gg, g squared.
Okay.
But you write down dy
Yes.
dx equal this.
Yeah, because...
Oh, that's dy dx.
So when the h goes to 0, this becomes
dy dx.
dy dx.
Oh, okay.
Is it okay? Is it okay? So this is the quotient rule.
So can I write the whole form?
Proof.
Because maybe I I think I missed the class in math one.
Yeah.
I think I should write down whole thing.
Oh, Ben, what are we going to do about them? What will we do? These two. They're
We're-
trouble.
No, we're genius. Just give us 2 minutes to write down these things.
Genius, huh?
Genius.
Uh-huh. I think Ben is the genius. He's finished first. Second. You got this all? Yeah. Okay? Yeah? You got that, Gav? Summer?
Yeah, I got it.
Okay. Let's have a look. Now, this is how I like to remember the rule. Bottom squared. Bottom times derivative of the top minus top times derivative of the bottom. So I'll give you an example, okay? Suppose you have y equals x squared over sine x. Right? The rule is the bottom squared. The bottom times derivative of the top minus the top times derivative of the bottom. Finished. That's the question. Let's try this one. So what's the derivative here? So it's the bottom squared The bottom times derivative of the top. What's that? 1. Minus the top, which is x, times derivative of the bottom.
X
X
over 1.
Well,
Well,
one
right.
over
One
X.
over x.
Well,
X times 1 over x.
One.
X squared.
1. 1. X
I
times 1 over x.
yeah.
Yeah. Okay. Right. Here is y equals tan x. Tan x equals sine x over cos x. I want all of you to use the rule on this. See what you can get. Yeah? No.
Huh?
Nope.
So this?
And
Huh?
say,
1 over cosine x squared.
correct. So look, the bottom squared. The bottom times derivative of the top minus the top times derivative of the bottom, and it's 2 minuses, so I'll make a plus. That's sine, cos squared plus sine squared.
Oh, this one.
But you learned this in maths part 1.
Yeah.
Derivative of tan x is 1 over cos squared.
So is that sine squared over cosine squared? Is that?
That's tan squared. Yeah.
Oh, so that's the same. One plus tan squared.
1 plus tan squared is 1 over cos squared. 1 plus tan squared is sine squared over cos squared. Plus cos squared over cos squared is 1 over cos squared. Yeah, it's the same. But don't write it like that, please. Yeah. Yeah?
Yeah.
Okay. So let's take this one here. Y equals 1 over 1 minus x. Prove it is decreasing for x more than 1. So I want you to prove that this is decreasing. Right? Now just think. What does it mean to say it's decreasing? What does that mean for the derivative? What does that mean for the derivative? What's decreasing?
So
Oh,
if the x is bigger, y is
smaller, yeah. So what does that mean for the derivative?
Minimum.
Maybe a minimum, not necessarily. No? Wait guys, you're not giving me the answer, so how can you start?
If we write down answer, we will see.
Okay, fine. Fine. Got an answer? Ben? Got an answer? Okay, no problem. Let me do it. So look. dy dx equals the bottom squared.
Yeah.
The bottom times derivative of the top, which is 0, minus the top times derivative of the bottom.
Zero.
Derivative of the bottom?
1 minus x.
Minus 1.
Minus 1.
Minus
Yeah?
Mm.
This is always less than 0.
Yeah.
Therefore, it's decreasing. Because remember, the dy dx means the slope
Of the tension.
of the tangent. And if it's negative, it means it's going down. Yeah?
Yeah.
Yeah?
Yeah.
Is okay?
So how to prove x?
Well, it's obvious because this here is minus 1 over something which is always positive.
Yeah.
So that's something that's always negative.
No, I said how to prove x over greater than 1. What's been decreasing for x greater than 1? Should I prove it?
No, I'm telling you, prove that's decreasing. So if x is bigger than 1, then this is less than 0. If x is bigger than 1, then this is less than 0. It also is true if x is less than 1. It's just not true if x is equal to 1. You know? You need to write it down? Wait, hang on. I thought we said we'd do the coursework tomorrow, on Wednesday.
I don't know. But tomorrow is for essay.
Yeah, for both, we said.
Just one class?
No, one maths class and one physics class.
Oh yeah, we have maths in the morning.
Yeah, I remember, this is what we said.
So,
So tomorrow. So we'll do the next lesson after
We
this.
will have 2 periods of maths.
Yeah, so for one of them. See, you confused me. You confused me. Got it? Yeah? Yeah? Okay. Now, let me give you a hard one to try. See if you can do this. Y equals sine x, cos x, x. And I want dy dx. Got an answer, guys?
Yes. 2 sine cos x x squared.
No. Well,
Is this?
maybe. I'll have to check.
This one?
Cosine x minus sine x over x.
Okay. Let's see. We're getting different answers. Let's see. So, look. You got it? The bottom squared.
Yeah.
The bottom times derivative of the top.
Is minus.
Well, the derivative of the top would be derivative of sine, which is cos,
Yeah.
minus
Cos.
sine squared. Because it's derivative of sine, which is cos, plus, and then sine and derivative of cos, which is minus sine, minus the top times derivative of the bottom, which is 1. So, that's the answer. The answer is x cos squared x minus x sine squared x minus sine x cos x over x squared. I don't think any of you got that.
In the previous class, I think you said if there is 2
Try trying to
cos
cut on
and
your-
2 cos x or 2 s sin cos.
What am I?
Say again?
In the previous class, you said that if there is both the cos in 2
Sorry.
places and the sine in 2 places, just put 2 cos sine.
Oh yeah, but this sine cos can't add with these ones because they're
Sorry.
squares, yeah?
I think it's 2 sine x
Okay, yeah,
cosine x.
over x squared.
Yes,
That's
2
2? Where's the 2?
minus sine x cosine x. I think it's 2 sine x and cosine.
Why 2?
But I think it's there has 1, there has 1. Or
Ah, Hang on.
you
hang on. We'll just start again. No, just watch. We'll start again. No, everybody look. We'll do it together. Okay, tell me if something you think is wrong. So, we want the derivative here, okay? So that's going to be the bottom squared.
Yeah.
X.
The bottom times derivative of the top, which I won't write in, I'll just write it like that.
Yeah.
Minus the top minus the top
Yeah.
times derivative of the bottom. Yeah?
Yeah.
so just 1.
So it's okay? So that's x. And then this is product rule. So cos squared x minus sine squared x. And this is just sine cos over x squared.
I just one question. So how to change sine x cosine x to
To this,
this? Yeah.
that's what we did in the last class.
Yeah. Just cosine x.
Yeah. It was, if you want somewhere, it was cos x plus sine x minus sine x.
Okay.
Yeah?
Yeah.
It's okay. Are you sure? Ben? Is that yes?
Yes.
Can I trust you? I'll give you one more, then I can trust you. Let's say y equals log x over x dx.
Log x.
Yeah. got an answer somewhere?
Maybe.
Maybe.
Yeah.
Go.
Just 1 minute.
Yeah? Let's have a look. So, it's the bottom squared. The bottom times derivative of the top
Yeah. Yeah.
minus the top times derivative of the bottom, which is 1ex plus xex. That's it.
Yeah. X square ax.
Yeah, but you can change it into ex minus ex log x
Yeah.
minus xex log x over x squared e2x.
And then we can
Yeah, we can.
Log
EX
Yes.
cancel something.
Yeah, I suppose.
So
You can cancel ex, so you can say this is 1 minus log x minus x log x, yeah, over x squared ex.
So I learn all the things, but I don't know what is ln square x. Like ln x.
Huh? What are you talking about? Where?
And from here, and I put all ln and the e.
No,
That's 1, so that's
no,
x.
it's not. No,
No?
no, you're confused. Log x ex is not the same as log ex. This ex multiplies this is not this. It's log x ex.
No, I put all ln on it.
Oh, you can't do that.
Why?
Why?
I can't.
Why?
Because I thought that we need to simplify this.
No. So like if you have 2 over 4, that's equal to 1 over 2. If you have log 2 over log 4, does that equal 1 over 2? I don't think so. You can check. What's log 2 over log 4?
Oh,
No, it's not.
It's not, so you can't do it.
Um, but I can put like some equals some, and I put ln
Yeah,
here.
you can do that.
But not the okay.
Yeah.
why get
Hey, it is a half.
It's half.
Okay, what about this? 1 plus 2 over 6. That should be a half. So, no. Let's try 2 plus 3 over 10. Maybe, I'm sorry, Gail. Maybe it does work. Let me check. Log 2 plus log 3 over log 10. No, that doesn't work. Okay, so that was an accident for this one. Yeah. But I do wonder, your question is A over B, does that equal log A over log B? Okay, Ben, give me a number for A, any number.
sorry.
Give me a number for B.
5.
Okay,
That's 0.6.
should be 0.6. Log 3 over log 5 equals 0.68. So it seems to only work for 1 over 2,
Okay.
or 2 over 4. Okay.
So we don't have to simplify them.
No.
Just
Alright, do you need to go back?
and see the last answer.
got that? Are we just waiting for Gail? You have that, Ben?
Oh yeah.
Somewhere?
Yeah.
Yeah? What's wrong, Gail?
No, I got confused.
Are you okay?
What? Okay.
Yes.
So what's the first bracket? What's the one
This one?
EX?
This?
Is that
That's the product rule for that.
Oh, that's product rules. I forgot. Sorry.
Okay. Let's try some from the book. Yeah. Good. So, let me see what would be good for you to do. Can I have can I mark some? Yeah, I'll tell you which ones to do. Listen, I'm going to tell you which ones to do. One F. Come on. What's the
Which
Ben? What? 96. What's the Chinese for hurry up? Go faster. That's it. I need to learn this. Right, are you ready? 1F, 1M. Khalifa, 96. Oh, you know the book. Yeah, you need to come see me. I can print you out the next one. N. W. And then
Okay, I will share.
2A, B, C, D. And 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. Should I give you one more?
No.
No, okay. 9's enough, I guess.
So what is log square x? Just log square x. Should we write square here?
No, brackets.
This.
Yeah.
Mhm.